You've never truly slept wrong in your life. Every night you close both eyes, your whole brain powers down, your body goes limp, and somehow that's the correct version of sleep. But dolphins have been doing it completely differently for millions of years, and what looks broken and creepy is actually one of the most sophisticated survival designs on the planet. So, do dolphins actually sleep at all? Can half a brain really be unconscious while the other half isn't? What happens if both halves crash at once? Like, why does one eye stay open? Like, is it literally watching for something? And are they dreaming right now, floating just under the surface? Like, guys, stick with this because the answer flips everything you think you know about sleep, brains, and what rest actually means. Picture this. You're at an aquarium or watching a nature documentary, and there's a dolphin near the surface, barely moving, drifting in a slow, lazy arc. One eye is shut. One eye is open and sort of staring. It looks wrong. It looks like a glitch. Your first instinct is that it's half awake, daydreaming, or just idling like a screensaver. Most people assume dolphins sleep the way fish do, just passively drifting with the current, not really doing much of anything. Or they assume dolphins sleep like us, fully unconscious somewhere safe. The reason the myth sticks is simple. We never see a dolphin lying down. There's no obvious sleep signal, no closed eyes, no stillness, no bedroom, no visible cue means people assume nothing is happening. But here's what's actually switching off inside that skull. Dolphins use something called unihemispheric slow wave sleep. That sounds like a textbook term, so here's the plain version. One hemisphere of the brain powers down completely into deep sleep while the other hemisphere stays fully awake and running. It's like your phone updating its software on one processor while the other processor keeps the screen on, and the GPS tracking. The sleeping half gets genuine, real neurological rest. The awake half keeps the body functional, and here's the part that makes the open eye make total sense. Each eye is wired to the opposite hemisphere. The open eye is connected to the awake half of the brain. It's not paranoia. It's not a nervous habit. That open eye is architecture. It's the awake brain's window. But that's not even the weird part. Dolphins are voluntary breathers. That's the piece most people don't know, and it changes everything. You breathe automatically right now without thinking. Your brainstem is managing every inhale. You could fall into a coma and you'd still breathe. Dolphins don't work that way. Every single breath is a conscious decision, which means if both brain hemispheres crashed at the same time, the way yours do every night, a dolphin would stop breathing, sink, and drown in its own sleep. The awake half of the brain isn't just keeping watch for predators, it's keeping the animal alive by managing surfacing, breathing, and basic navigation. The open eye isn't watching for sharks, it's the reminder that the body still needs to come up for air. So, what does the sleeping half actually get? Genuine restoration, real slow wave sleep. The brain clears waste, consolidates whatever passes for dolphin memory, resets. Just one side at a time, on rotation. Now here's a quick contrast worth making because this is where people get confused. When you sleep, you go fully offline. Total body paralysis, complete unconsciousness, and REM cycles where your brain gets wildly active again and you dream in full narrative. Dolphins likely skip or dramatically compress REM sleep. Scientists still debate exactly how much, but the consensus leans toward dolphins getting far less of it. Now, you couldn't function doing what dolphins do. Your brain needs the full shutdown. And a dolphin couldn't survive doing what you do. It would simply never wake up. But dolphins aren't the only ones running this system. Some migratory birds use the same half-brain trick mid-flight, staying airborne for days without fully stopping. Same solution, completely different animal. Evolution apparently found this answer more than once, which tells you how useful it is when you genuinely cannot afford to stop moving. Here's where it gets cinematic. Roughly 50 million years ago, the ancestors of modern dolphins were land animals, 4 legs, walking on solid ground, sleeping the way most mammals sleep, completely, safely, horizontally. Then, slowly, they moved into the ocean, and the ocean has no pause button. Predators don't take breaks. Currents don't wait. Breathing doesn't happen automatically anymore when you're underwater. Natural selection didn't eliminate sleep. The brain still needed it too badly, but it did something more interesting. It split sleep in half. The half brain system wasn't invented in a single generation. It was carved out slowly over millions of years of dolphins that slept too deeply and didn't surface in time. The ones that survived were the ones whose brains had already started rotating the shutdown. I'll take what looks like a weird quirk is the accumulated solution to an impossible problem. And once you know this, you start spotting echoes of it everywhere. Your dog twitching and whimpering in a dream right now, like fully offline, both hemispheres down, completely unlike a dolphin. The duck sleeping in a line along a pond edge. The ones on the outside of the group use half-brain sleep with one eye open facing outward, while the ducks safely in the middle sleep fully. Documentaries showing dolphins logging that flat, barely moving drift near the surface, that's the sleep position. Aquarium dolphins doing slow, gentle loops with one eye closed. The phrase sleeping with one eye open that humans use as a metaphor for suspicion or vigilance. Dolphins aren't being metaphorical. They literally do it structurally every single day of their lives. Sea otters floating on their backs, holding hands to avoid drifting apart. Different trick, same ocean problem. Ice sharks that must keep water moving over their gills or they suffocate. They solve it by resting in stages too, letting different parts of the nervous system take turns. Every time you see a wildlife clip of dolphins barely moving at dawn, you're watching a precision-engineered sleep system in action. Now, the honest caveat, because it's not a free lunch, half-brain sleep is likely less restorative per hour than full sleep. One theory is that dolphins compensate by sleeping more total hours overall, running both hemispheres through the process in longer rotations. It's a trade-off, not a superpower with zero cost, and the system isn't invincible. Stress, noise pollution from boat engines, and the cramped conditions of captivity can all disrupt even this highly adapted sleep. The ocean doesn't cooperate perfectly, and neither does the modern world they've ended up sharing with us. So here's the reset. If you looked at that drifting dolphin with one eye open and thought, glitchy, creepy, half-functional, turns out you were watching one of the most elegant biological engineering solutions on Earth. A brain that found a way to rest without ever fully switching off, built over millions of years of an animal that had no other choice. Next time you see a dolphin barely moving at the surface, you're not watching it zone out. You're watching half a brain sleep while the other half keeps it breathing. Keeps it moving, keeps it alive. That's not broken, that's the upgrade.